This video will deal with the simplest of the homologous series called the alkanes. Alkanes are identified as hydrocarbons that contain only single carbon-carbon bonds. Remember, hydrocarbons are compounds that contain only carbon and hydrogen atoms, and if the compound has only single bonds between the carbon atoms, we then identify it as being a saturated compound. Saturated hydrocarbons have only single bonds between carbon atoms. Now, the alkanes are common fuels if you use gas to cook your food, or if you go camping and use gas, then that gas mixture is propane and butane, which are both alkanes. The shorter chain alkanes are gases at room temperature, methane, ethane, propane and butane, all gases at room temperature. The longer ones become liquids from pentane onwards, and then they slowly move towards the solids when we get about 20 carbons in the chain. Alkanes have weak van der Waals forces between the molecules because they're symmetrical molecules, and that becomes important when we start to consider the physical properties of alkanes. And then finally, the longer chain alkanes are used as additives in petrol. Octane is used in petrol, and some of the longer chains also used for diesel and waxes. Alright, let's consider how we go about naming the alkanes. Remember that any name of an organic compound at its simplest contains two parts: the prefix, which indicates the number of carbon atoms, and the suffix, which indicates the homologous series. So if we look at this alkane, it's got two carbons, it's only got a single bond between the carbon atoms, and so that defines it as an alkane, which means that its suffix is ane, A-N-E, that's the suffix for alkanes. There are two carbon atoms, and the prefix for a chain that has two carbon atoms is F, and so the name of that compound is ethane. Right, let's have a look at another example. Once again, this carbon compound has got only single bonds between the carbon atoms, so it's an alkane. If we number the carbons, you'll see there are 4 carbon atoms in the chain, and so our suffix once again is ane because it's an alkane. Our prefix for 4 carbons is but, and so the name of this compound is butane. Alright, now let's have a look at naming alkanes that have got branches. I'm going to start with a warning. Be careful here. Your examiners will try and trick you by drawing a straight chain and then put a little kink in it. Remember, these chains are never straight because of the nature of the bonding, and so when they draw it like that, they're simply trying to trick you into thinking that that's a branch. If we put the hydrogens in, what they're trying to do is say, hey, is that a branch or isn't it? And the way you check is to simply start at the one end of the chain and draw a straight line through the carbons that are directly attached to each other. And you can see there's no branch there. It just turns the corner. So that's not a branch, and don't be fooled by that. With a straight chain, well, with a length of chain with 5 carbons, that's simply called pentane. All right, let's look at this compound. This one does have a branch, and the way we identify it is that that carbon atom there has got 2 carbons bonded on either side of it as part of the main chain, and then a 3rd carbon that is a branch. So if we draw in, there's the straight chain, there's the carbon attached to its 2 neighboring carbon atoms, and that then is a carbon atom that branches off that main chain. So we definitely do have a branch, and we have to think about how we're going to name that. I put in all the hydrogens now, and let's go about systematically naming it. There's our branch, and we call branches alkyl groups. Any hydrocarbon that branches off a chain is given the name an alkyl group. The specific name depends on how many carbon atoms are in that branch. So, if we've got a single carbon with its 3 hydrogens as the branch, we call that a methyl group. Meth, meaning 1 carbon, and yl comes from the alkyl group. If the branch has got 2 carbons, then we call it an ethyl group. eth from the 2 carbons, and again the yl from the alkyl group. Our syllabus only covers branches with 1 and 2 carbons, so we'll only be dealing with methyl and ethyl groups. Alright, let's go back to naming this. The first thing we have to do is identify the longest chain. And so you simply start at one end of the molecule and you identify where the longest chain is. And this particular one has got 5 carbons. Secondly, we number the chain in such a way as to give the carbon on which the branch sits the lowest number. So if we start numbering from left to right, then we'd see that the branch sits on carbon number 4. However, if we number from right to left, you see the carbon fits on number 2. Now remember, these are 3-dimensional molecules that can flip over in space, and so whether we number from left to right or right to left is entirely irrelevant. So there's our branch on carbon number 2. So we go ahead and name it. We start by indicating the number on which the branch sits. So it sits on carbon number 2. We then put a dash. We always have dashes between numbers and letters. And it's a methyl group because there's 1 carbon in the branch. So 2-methyl. And then our main alkane has got 5 carbons, and so it's pentane. So 2-methyl pentane is the name of that particular compound. Alright, let's have a look at naming another branched alkane. Let's try and name that one. I haven't put hydrogens in yet. I will do so in a moment. First step is to identify the longest chain, and you may be tempted to say that's the longest chain. It's got 6 carbons, but if we have a look, there's a carbon chain, a continuous carbon chain that goes down. Now remember, that's just a trick of the examiners. It's still just a single chain, and that one has got 7 carbons, so that's the longest chain, which then means that we have got 2 branches. We've got to now number the chain, so the branches get the lowest number, so we start from the left and our branches are on 2 and 5. If we started from the other side, they would be on 3 and 6, and so this way gives it the lowest number. So the name of this compound then is 2,5-dimethyl heptane. Let's go through it step by step. The 2,5, that indicates that the methyl groups are on carbons number 2 and number 5. So we separate them with a comma, and we put a dash between numbers and letters. Di indicates that there are 2 methyl groups. Methyl means that the groups have got 1 carbon atom in each group. That's where the meth, the yl, indicates that it's a branch. Hept means that there's 7 carbons in the main chain, and ane means that that main chain is a compound from the alkane homologous series. So it's 2,5-dimethyl heptane. Alright, let's have a look at drawing alkanes with branches. So we're given the name, and we have to then draw the compound. We'll use 4-ethyl 2-methyl octane as the example. Let's start with the backbone. It's got an octane backbone, and so we need to draw 8 carbon atoms, and I've just numbered them there for us. Notice that the 4-ethyl is written before the 2-methyl. The convention says that the substituents on the main chain are ordered according to alphabetical order, not numerical order. So the E for ethyl comes before the M for methyl. All right, 4-ethyl, that means on carbon number 4 we have an ethyl group. That's a 2-carbon group. And the 2-methyl, on carbon number 2 we have a methyl group, a single carbon branch. We then put in all the other bonds. Remember, every carbon atom must have 4 bonds, so check carefully. We then put in all the hydrogens and get rid of the numbers. You can just go through and make sure every carbon has got 4 bonds. The 4-ethyl, there's our branch on carbon 4. The 2-methyl, our branch on carbon 2. Right, let's consider the general formula for alkanes. I'm going to put a little table in here with the first 4, methane through to butane, and then we'll see if we can work out the general formula. Let's start with methane. It's got 1 carbon and 4 hydrogens, and so CH4 is its formula. Ethane has got 2 carbons, so C2, and then if we put in the hydrogens we'll see that there's 6, so C2H6. Propane, 3 carbons, And if we count up the hydrogens, we'll see there are 8 of those, so C3H8. Butane has got 4 carbons. Now notice that each of those carbons must have 2 hydrogens. We call those the CH2 groups. And then the end, or the terminal carbons on each side, have got an additional hydrogen. And so that's C4. If you count them up, H10. Now what about the general formula? What we mean here is if we've got N carbons, so we don't know how many, just some number N, how many hydrogens do we have? Let's draw N carbons. They're the first 2, and then we've got a whole lot. We don't know how many, and there's the end one. Now, as I did for butane, notice that each carbon in the chain has to have 2 hydrogens. So if they're N carbons, then we have to have 2 N hydrogens. And then the terminal carbons, the one on either end of the molecule, must each have an additional one, so that's an extra 2 hydrogens, and so we need to add in 2. So the general formula for alkanes is CN H2N plus 2.